Good morning, everybody. It's a pleasure to welcome you to Swansea to this Technology Day, which is run jointly, as John pointed out, between SERB and the Welsh European Funding Office funded ASTUTE project. And my presentation is entitled, How Can ASTUTE Help SMEs? As I said, my name is Professor Johann Sienz. I'm the project director. Before we start, what does ASTUTE actually stand for? ASTUTE stands for Advanced Sustainable Manufacturing Technologies, and it's a partnership of the Welsh universities. They're all listed down here: Aberystwyth, Bangor, Cardiff, Cardiff Metropolitan, Glyndŵr, Newport, Swansea, and Swansea Metropolitan University, spread throughout Wales, and they are targeted, and this project is targeted to work with companies in the convergence funding area, which is the dark shaded area here. Naturally, we are not only limited to work with those companies, we can work with larger companies work outside the convergence funding as well, as long as the supply chain extends into the convergence funding area. The rationale behind ASTUTE is that manufacturing is a complex process. Typically what you've got is at the input, you've got people, knowledge, and research and development, which needs to be carried out by those people. You've got raw materials and energy, and in manufacturing you need to use advanced technology to convert and process all this while being environmentally sustainable to get the products out which you can actually pass on to the market then and sell, which is your profit, by minimizing waste and emissions while also being sustainable. So this project was set up to formally enable the manufacturing industry in the West Wales and the valleys to cope by adopting more advanced technologies and at the same time improve the sustainability by reducing its environmental impact. We do this via a partnership, which I've already listed, of the 8 universities there. So basically we tap into the knowledge base of the universities and work collaboratively with companies for the benefit of the companies. So to bridge this gap, where universities are seen as ivory tower, they do fantastic stuff, but it's not really relevant to companies. And this project is specifically designed to collaborate with companies to deliver for the benefit of the companies. Overall, the time frame is 5 years. We started in May 2010. We run till April 2015. The overall project value is 27 million. And from this, it's made up of 2 components. This is the public money from the Welsh European Funding Office, 14.3 million. And the universities contribute 13 million. So the universities are strong stakeholders in it, and they finance it to virtually 50%. Overall, we've got 50 technical staff, some of which are here. So we've got Metala, Farsi, Martoon, Shahid, Marty, where's Marty? Sitting there in the back. John is an ASTUTE employee now as well. So lots of people working on this, a wide range of expertise. And we've got administrative staff. You've met already Emma, Anke, and Rian, and David in the back there. And yes, there's David Natural there as well, technical manager. Sorry, I completely overlooked you. And plus, so this is the team which is paid for by WEFO. We've also got then the expertise of the academics, which come free of charge. So they are brought into the project as and when needed, depending on the project when it's defined. And so it's quite a strong partnership, which allows us to work quite comprehensively with companies across a very wide range of topics. The scope is manufacturing, and we take it in the broadest sense. So anything which has to do with manufacturing, we will look at. And initially we specified aerospace, automotive, and high technology, high value added manufacturing. It's very broad. So for any company which had something to do, which has remotely to do with manufacturing, we actually sat down, we did discussions with them and see whether we can take it forward. And manufacturing, we start with design and innovation. So it's design for manufacture. Can we redesign it to manufacture it more cheaply? It has got a strong component of modeling, analysis, and simulation in it. So computer-aided engineering, virtual prototyping, material selection, materials testing, Then the manufacturing route, the simulation of the manufacturing routes, so a wide range of things which we can look at. We can also do life cycle analysis and market deployment. So as you can see, when we talk about manufacturing, we really mean it's a very broad scope. The expertise matrix, which is available across the project, it's not complete. You see here the partners on top, and you see roughly the expertise down here. So we've got, for instance, software partners in there, Aberystwyth. We've got photonics, which comes from Bangor and Cardiff. Materials, which is Glyndŵr and Swansea. Then we've got non-destructive testing, which comes from Swansea Met. Robotics, additive manufacturing, lean manufacturing, a wide range of expertise. And the most important thing is that if you think you've got a problem as a company or would like to discuss a collaborative project, then the best thing is to give us a call, and we sit down then to discuss it. Just to give an idea about Swansea expertise, our partners have got an equal impressive sheet of expertise which they've got available. We've got here the areas of expertise, which start product design and innovation, computer modeling, software, materials, and so on, down to simulation-driven product design and optimization. The software we use is fairly wide-ranged. This is actually wrong. Abacus, Altair, ANSYS, AutoCAD, CATIA, FEMSYS, Fluent, Alestina, MATLAB. They should read now Moldix because they are our new partners, and we're quite happy to have you here today. We used to use Moldflow, and Moldix made us an offer which we couldn't refuse, and it's an excellent piece of software, and we're looking forward to work with you over the next few years on research and development and exploring the software. And Physica, which is for multiphysics. Experimental facilities, from testing to mass spectroscopy, injection molding, DMTA, electron microscopes, down to X-ray spectroscopy, ultraviolet testing. So a wide range of testing facilities. We've also got reverse engineering. We just purchased a new 3D additive layer manufacturing machine for metals, so we can do actually conformal cooling tools if we need to. And we use this on a wide range of areas: aerodynamics, dynamics, fluid dynamics, fluid structure induction, and so on. This is what we've got. Lately, we also started working with the other projects which have been funded in a similar way, one of which is, for instance, High Performance Computing Wales, where they've got a big computer, but they haven't got the software nor the expertise to actually run it. And so we start now a joint project with them where they provide the computing resources with a local company here around Swansea, and we provide the expertise, and we run the problems for them. And this is quite a good project to show collaboration on this level as well. So this is not limited to what is on the sheet. We've got by far more, and if we haven't got it on our sheets, we try to get it to make the project work. Very important, technology is important, but for companies more and more important becomes what we call cross-cutting themes. And the first one here is environmental management systems. Those are things which aspects of the business which need to be addressed by companies regarding corporate image, financial savings, and simply compliance with legislation. But rather than me talking about something which is not my area of expertise, we are fortunate to have Angela here. If you wave your hand, Angela, she, on behalf of ASTUTE, she delivers the cross-cutting themes. So companies, we can offer this to companies as well to help with environmental management systems with a range of support which Angela can advise you on how to do this. The same is true for equality, diversity, strategies and policy. Again, it's a target which we need to deliver, and again, it becomes more and more important for companies to be up to date on this, and again, Angela will be able to advise you on how we can help you on that. So let's look at a few of the things we've done so far, and this is a by far not complete. It's just a few things which I've picked out. Electronics, there's a company which does circuit boards for the automotive industry, and we started to look at lead-free soldering, nanosintering for them. They had issues. They wanted to get away from lead solder to lead-free solder. We then advised them possibly to do nanosintering. We did computational analysis, we did thermal analysis, we did fatigue analysis, and we advised them on process route and material selection. And naturally, we did some metallography for them as well. So this is, and this was to help them to win a new customer for this product line. We did work on powder metallurgy. So powder pouring, as you can see, we did the simulations for it, compaction, sintering, infiltration. Again, a lot of modeling behind it, multi-scale and multi-physics to understand the process better and to design it. And again, some metallography and microscopy behind it. Yes, we do injection molding as well. We've done a project where we looked at a specific tool which didn't perform as it was supposed to. And we did a full analysis of this, computer-aided analysis, stressing. We did some injection filling simulations to see how this works. And again, we advised the company on how to improve their product. From previous project, we did some injection molding, and this expertise is naturally available via ASTUTE as well, where here's a car door handle. Here you see the filling process, a classical simulation. Then here you can see how to core out, how this handle is cored out by injecting gas. And then this is the secondary penetration, the cooling down. But we've got a presentation about this afterwards, and there are lots of samples in the back which use this technology. And again, we're looking forward to work with Moldex on this to do the simulations and to move things forward. Other things we've done is vacuum casting. This is an aerospace company which looked at a novel manufacturing process for their turbine blades. And basically, they tried to use commercial software which couldn't handle the projects. And they came to Swansea, and we used the in-house multi-physics code to solve those problems. And they implemented this new manufacturing route now into their company. We worked on high-strength steels, where we looked at heat treatment schedules, compositional optimization, hot mill optimization process. So basically, we did a lot of data collection. We looked then at the processing parameters, and we tried to optimize those to make sure that what comes out actually meets the requirement for specifically high-strength steels in this case. We also did a lot of metallography, and we look at corrosion for those. So the application would be automotive industries. We did some work on materials for medical devices, where we tried a joint project between Cardiff and Swansea. And the idea here was to replace the multi-use instruments with single-use instruments to avoid cross-infection. The sterilization units in the hospitals, they will assure you that the sterilization works, but there seems to be literature out there which says it doesn't for certain types of pollutions. And therefore, this company, with this company, we looked whether we can do something differently, and we looked at injection molding, whether we can injection mold those products to make them basically single use, and once you've used them, you can't sterilize them. If you put them in an autoclave, they actually decompose. We didn't succeed in this because we couldn't get the necessary stiffness, even if we looked at very exotic polymers filled, and therefore we are looking at possibly overmolding now metals. We worked on a range of medical devices. Here's a blood oxygenation device where we did some simulation where we modeled this as blood going through a porous media. Again, to advise the company on how to redesign this to make it work. We've done some work on an insulin pump, which injects you automatically, depending, it measures your blood level, your sugar level, and then it automatically injects you with the insulin. And there were some issues there, so we did some CFD on it and free surface flow. And we also worked with a company on heart pump design, where we again do simulation of the blood flow, and we look at pump efficiency, naturally. We also look at thermal modeling, electromagnetic modeling, and we give typically on all those things manufacturing advice. Thermal modeling for the heart pump is quite important, in addition to the efficiency and naturally also the damage the pump does to the blood. Because if this gets too hot, then you start to damage the tissue around it and you destroy the heart. So it's a complex thing where we need to electromagnetic and thermal modeling to see what kind of performance we get out of this heart pump. We do casting simulation, and again, a wide range of simulation, so CFD, thermal distribution, coupling with thermal coupling with the mold, shrinkage, predictions, and stresses, but also metallography, which goes along with that. We work on process improvements, where this is a company we work with where we basically use failure mode analysis and ontology to improve the productivity. So we look at the manufacturing process, we capture data along it, and we try to extract where things go wrong or where things can be improved. And for this, we've worked with this company now for over 2 years, and it's a fantastic project. It's quite incredible how much data you get out of a manufacturing process, which is sitting on everybody's desk, on everybody's drawer, and it's not used by the company to actually improve the process. And we're developing something now, I always forget the name, Smart Wiki Plus. Semantic Media Wiki Plus. And it's basically an intelligent way of collecting all this data, querying it, and trying to connect it together to see where things go wrong. We do some electron microscopy, just to give you an example. So this is for coated surface, and we look at what you've actually manufactured, what comes out at the end of your process. This is non-destructive testing, where our partner looks at developing a bespoke process for a company, where they look at developing and simulating this device here, so that they look at the failure and error detection in the structural part below. We've been running now for just over 2 years, and this is the company list that we've been working. This is not quite up to date, February 2012. So we've got a wide range of companies which we've already engaged with, and there's some of them are represented here today. It's been an exciting startup phase, and all the projects have been very, very interesting to us, and I believe also very beneficial to the companies. There are some quotes from individuals who we have assisted, and basically this is from, the first one is from Mike Evans, Managing Director of EBS Automotion Limited in Llanelli, and rather than me reading it out, I leave it to you to read through it. And the second one is by Gareth Jenkins, the Managing Director of F&G Tool and Die. We're very proud on any of those statements. I think the last one here, it shows a typical scenario where a company is struggling with a problem, and we, by doing collaborative projects now with companies within ASTUTE, we can actually solve the problems jointly, and they gain then more productivity. So how do you engage with us? The easiest is naturally you contact us, and the companies then basically we have a process where we look at each of the projects. So when we receive a company contact, we go to the company and we start to discuss what is the problem of the project which needs to be done collaboratively. We've got a fairly informal approval process. We then cost this project, we evaluate it. We've got an internal process to make this happen, so we don't need to ask anybody else. We just need to do a check on our side, and then we can proceed with the projects. If it's a smaller project, we can approve it within a couple of weeks. If it's a larger project, most probably it takes around 4 weeks, and even larger ones, they take around 6 weeks to approve. And then we allocate the resources, we bring the project team together, and we engage with the company. The projects we run are typically collaboratively, which means that the company puts in work as well. So it's your engineer's time. If you manufacture a prototype and so on, this is what will be taken as the company contribution. And as it's collaborative, it doesn't cost the company any money. So that's very important. There's no cash interaction between our project and the company. It's not free because the company needs to do it collaboratively, so we need a contribution, a matching contribution from the companies. But when it comes to cash, there's no transaction involved. And as it's collaboratively, also we look then at the intellectual property right, IPR, which comes out of it. And typically, we split it in such a way that the company gets what they would like to retain and what is useful for their business, while we retain typically the knowledge how we gained that we gained during doing this project. So it's fairly beneficial to the company, and it's all down to talking and negotiation while we do the project scoping. And once this is done, we deliver the project, and at the end, naturally, we're not funded just for the sake of it. We'll come back to you and we'll ask you what kind of impact this had on your company, such as, did you create any jobs? Did you improve your equality opportunities? Did you use less energy? Or did you, for instance, bring a new product to the market? So those things are which we need to collect then, this data, and this feeds them back to our funding agency. Okay, thank you very much. This is a short overview of ASTUTE. If you've got further questions, David Bolt, technical manager on ASTUTE, he will be able to answer questions, but there's also Mahdi in the background, and Shahid Mahtoun and others, and myself naturally. Thank you very much.